Welcome, my awesome friend. I hope you all are great. Today's lecture, we are going to discuss the PVsys software 7.2. It's basically similar to PVsys 6.8. It also used to design the electrical design. For the mechanical design, it also requires another software. But you can see right here, it also has a menus. Here you can find the preliminary design. This for the project. Also, PVsys 7.2 could be used for grid-connected project or standalone project or pumping project or DC grid project. Here you can find the file menu where you can import or export any component you want, like inverters, DC charger, PV modules, any component in the PV system. Also, you can import or export projects. Here you can find the preliminary design, like the grid-connected and standalone and the pumping system. Here you can find in settings menu, the preference. You can find here the preference menu. Here you can add any logo you want, if you want to add any logo from your computer. Also, you can find here all information you need to add of your company, like company name, personal contact address, zip code, country, and other things related to your company. Okay, after that, if you want to change the language, you can change it easily from right here. Also, you can see the default values for irradiation and the energy. For irradiation, you have one of two options, watt per meter square or megajoule per meter square per hour. Also, the energy units, you have one of two options, kilowatt hour or megajoule. For pressure, you have multiple units like bar, PSI, kilopascal, and the other things. Here also you can find the flow rate. Also, you can find the water volume per day. Also, the discharge rate in amp or hours. Also, you can choose the automatically project loading, as when you close the PVsys and reopen it again, you want the PVsys open a new project or open the last opened project. Also, you can find other menus right here related to your project. Also, you can find the language menu if you want to change the language of the system easily. Let's go back to English. Also, you can find the license details and help. Okay, let's start with a small preliminary design. Let's start with the grid connected. Here, similar to PVsys 6.8, the same menu. You can change the site and meter from right here. To choose the site you want built in the PV system. Here you will find the country you are working on. I'm going to leave it as United Kingdom and the site as London. As the same, also you can find the longitude and latitude from open site. Wait for it. Longitude and latitude from right here. Also, you can find the monthly meter here. Also, if you want to see the map, right here. Okay. After choosing the location, let's press OK. After that, also you can see from horizon here, you can find the irradiation or along the day. You can see it right here. This is the sun height and the horizontal line drawing. You can see it easily from right here. Okay, let's start with designing the system. If your customer has already bought an area and specify this area for PV system, you can enter here the meter square of area. Let's say 200 meter square, or let's say 500 meter square. This 500 meter square is going to give you about nominal peak power of 75 kilowatt peak, or annual yield of 70.3 megawatt hour per year. Also, you can find right here the losses according to mounting. You have two parameters you will need to enter to reduce the losses. As you can see here, this parameter is the tilt angle and the azimuth angle. The tilt angle, to choose the best tilt angle or azimuth angle, you will need to show the optimization. As you can see right here, you have the optimization for the annual yield, or for the entire year, or for only the summer months, or for winter. Let's choose for the entire year, the annual yield. As you can see right here, the losses according to the tilt angle is about minus 3.8%. To change the tilt angle, all you need is to press on the red dot and change it. We won't change this tilt angle until the losses become 0. Let's change it until the losses become 0. So the best tilt angle is 37 degrees. This will cause 0% losses. So for our location, we will need tilt angle of 36.85 and 0 azimuth angle. Okay, let's press next. After that, let's choose the type of module type. Do you want it as a standard module, or you want it to customize your module? It's easily to customize the cells inside the module from right here. Okay, I'm gonna leave it as a standard. Here you can find the technology used for the modules. You have one of three options: monocrystalline cell, polycrystalline cell, thin film. I'm gonna choose the polycrystalline cells, as the polycrystalline cells is the most common types, as it's cheap and also higher efficiency than thin film. Also, you can find here the mounting this position. The mounting this position is basically where you will mount your PV system. Will you mount it on the roof of the building, or you will mount it on the ground basis, or on the tilt roof? I'm gonna choose the flat roof. Okay. For the ventilation, you have one of three options. The first one is the free air circulation. This basically here below the PV modules is going to be ventilated by a free air. Here you will have a semi-integration or semi-ventilation. You will need some sort of ventilation behind the PV modules, or the PV modules is fully insulated and there is no ventilation behind the PV modules. I'm going to choose the semi-ventilation, the second one, and press OK. After that, let's see the result of the system. The input data for our system is the place is the London. Okay. The annual yield for the system is about 70.3 megawatt hour per year. Also, you can find here the value of the cost of modules. Basically, it could be 8 watt. So I'm gonna choose this as €1 per watt. This means if you have 150 watt module, this means this module will cost you 150 euro. This project will have a result of area about 507 meters square and nominal power about 76 kilowatt, and the investment cost is going to be about 210,049 euro. And also the energy cost is going to be 0.2 euro per kilowatt hour. Here you can find the irradiation all over the entire year as kilowatt hour meter per meter square per day. This is the average radiation in each month and in the entire year right here. Also, you can find right here the system output or the energy yield here for each month and right there for the entire year. As you can see, the average energy is higher in the summer than the winter, and also you can find here the entire energy yield for each month here separately right here. Okay, kilowatt hour and also the horizon global. Here you can find the entire cost. You will have a module's cost about 76,000 euro, and also support cost is going to be about 52,695 euro, and the inverter and wiring costs are going to be 15,200 euro, and also the mounting and transport is going to be 66,152 euro. The entire investment cost is going to be 210,049 euro, and the maintenance cost and other costs you will find there. And so the total cost per year is going to be 14,031 euro per year. This means the energy cost will affect you actually is 0.2 euro per kilowatt hour. If you have this investment cost according to loan, this loan is the duration of 20 years, and the rate of this loan is, let's say, 5%. So you can change the entire investment cost. If you want to edit any cost of anything, you can edit easily from right here. Okay. And let's press next. Let's save it and save. Okay. Okay, guys, that's for today. Thank you for watching. See you in the next lecture. Bye-bye.